Hello everyone. This video is about trustworthiness in DevOps. I'm Huawei Cloud Dev Cloud Architect. Ifei. English name is Kevin Lee. I'm primarily responsible for Git repository, security, and patents. Today, I will introduce the Dev Cloud features and give a brief introduction to our experience in trustworthiness. In the era of digital transformation, rapid and continuous delivery of software has been on top of the agenda for many companies. To help these companies with developer DevOps transformation, the cloud has launched a one-stop, full-process, secure, and trustworthy DevOps platform. The entire software lifecycle, from requirement planning, development, testing, deployment to O&M is covered in the cloud, which has released 13 services. As an end-to-end R&D toolchain, the cloud will be your right hand on every phase of the development. In the continuous playing phase, Scrum, Kanban projects are provided for agile management. Teams of all sizes can choose the one that suits them best. In the continuous development phase, you can use Git for distributed collaborative development. The cloud enables builds using containers and supports popular programming languages. Build environment can also be customized. The cloud also provides Cloud IDE, a cloud-based web development environment. It supports 40 programming languages. Many open source components are available for download at Huawei Millers. In the continuous testing phase, the cloud provides test management, API testing, and performance testing. You can perform code-free testing on RESTful and Swagger APIs. In the continuous deployment phase, the cloud provides cloud deploy, cloud release, and cloud pipeline. Cloud pipeline allows you to create a pipeline to orchestrate code checks, builds, tests, and deployment in a parallel or serial manner. You can then run the pipeline in one click. The delivery efficiency is thereby greatly improved. In Huawei, we believe that trustworthiness is the degree of certainty that each system has 6 characteristics: reliability, availability, security, redundancy, privacy, safety. Reliability, the ability to perform as required without failure for a given time interval under given conditions. Availability, the ability to be in a state to perform when required. Security, the ability of the system to remain protected against malicious, deliberate threats. Redundancy, the ability of against attack and recover. Privacy, the ability to provide for the rights. Safety, dealing with the malfunctioning behavior of the system. Essential features of the trustworthiness approach is confidentiality, integrity by the traceability. Confidentiality is the ability to keep information from being disclosed. Integrity, the product is complete from development to delivery to the customer through the supply chain and has not been maliciously contaminated or counterfeited. Traceability, the degree of certainty that each entity of a product has a reason for being. Our E2E software lifecycle also need to guarantee these characteristics. For the sake of time, let's take integrity as an example for analysis and discussion. During the development process, we may encounter the following risks: open source components, backdoors, third-party software logic bombs, external attacker infiltrating device, resulting in backdoors being planted in products. At the build stage, also infiltrate the tools leading to product implantation of backdoors. At the test stage, attackers attacking the testing services to falsify test results and have the backdoor go undetected. All stage and the system face the threats. Lots of problems are revealed and real and have occurred at many well-known vendors. How do we mitigate these risks? During the development phase, we have some advices. First, management the dependencies. During input risks, vulnerabilities, and maintenance capabilities. We can provide dependency vulnerability management, trusted checking, selection management, security scanning, and other capabilities. Second, in terms of coding, programming to meet the clean code principle, we can ensure that the clean code principles are well defined and can be enforced consistently using IDEs or other tools. We also can provide static and dynamic code analysis tools to determine rule checking. Committer mechanism, for example, single function code submissions, peer reviews, separation of code entry rights, etc. Code-based security, exception checking and management. For example, to strengthen our system, we add critical event analysis, alerting for abnormal behavior analysis, two-factor authentication, encrypted storage, etc. Every change is recorded and traceable to a reason. Traceability is a guarantee, and commit integrity protection can be done using such as GPG signatures. Traceability of code, design, and requirements. We do this to make sure every line of code has a purpose and meaning. During the build phase, the suggestion is process defined and the environment is secure. The environment is confidential and traceable to exceptions. Binaries and release binaries are compatible. Each release binaries can be regenerated at any time with all components. And all release deliverables are saved for analysis. We can provide code build package conformance assurance, such as include GPG signature, integrity, checking of code, build environment cleanup and rebuild, build environment isolation, shareable environment, dedicate network, package integrity logging, private component change checking, and timely notification, etc. There is a wide range of test tools. I use cloud test diagram as an example. During the test phase, we have the following suggestions. Automated tests are defined and the test environment is secure. For example, private clusters, resource isolation, avoiding interference from other users, more realistic results. Full volume regression tests ready for execution. We can provide the following capabilities: real-time feedback of test results, multi-environment pipeline automation testing, cloud-based elastic resource pooling, bulk reuse of test assets. Requirements use case defect by the traceability to ensure efficient product acceptance. In terms of validation, we can use web vulnerability detection, ISS security checks, APT attack detection, etc., to help the system to solve the problem. During the deploy phase, our advice is trusted provision process, secure operational process, trusted operational tools, trusted deployment acceptance, trusted integration, and customization. We get the deployment package with integrity checks for make sure the deployment channel is safe and secure. You can use security protocols all through fortress machines. Installing and deploying requires full logging for post-mortem analysis, and our patch release deployment need to be fast and effective. Once deployed to the ops platform, we can support the routing operations such as application upgrades, start and stop, monitoring, and support for highly available container clusters, microservice governance, service hosting, etc. During the O&M phase, our advice is get the ability to troubleshoot same product equipment, ability to troubleshoot vulnerabilities of the same type across all products, ability to find root causes, and consistently enforceable measures for this type of vulnerability. Graceful degradation, emergency response plan in place and rehearsed. External disclosure of vulnerabilities meets specifications. Isolation and reversal. Intrusion detection. Trojan removal. Well, we have shared some of the characteristics required for a trustworthy process today. And if you are interested, we will continue to communicate offline. Thank you. Goodbye.